Okay, today's Monday, March 4th, and we are doing Module 4, Lesson 17. Today our learning goal says I can explain how fraction and decimal multiplication are related. So we already know how to multiply decimals. We know we have to change the problem and then undo it. Yes? We're going to see how that relates to fraction multiplication now that we're starting to learn more about fraction multiplication. Here we have a problem, 0.1 times 4. Go ahead and write that in your math notebook. 0.1 times 4. We know how to multiply decimals using unit form and also using standard form. So let's talk about that. If I want to use unit form, I have 0.1. How do I say 0.1 using unit form? There's 1/10 because the 1 is in the tenths place. So this is 1/10. 4 copies of 1/10, right? So if I have 4 copies of 1/10, what do I have?
4/10.
4/10. And how do I write 4/10 using standard form?
0.4.
Because I want the 4 to be in the tenths place. For those of us who were not comfortable with the units, place value units, that was all the way back in Module 1. We're now in Module 4. It doesn't mean we forgot about it. It means we still need to know how to use it. It's going to come back again and again and again. Okay, so you need to know your place value units. Very good. So therefore, using unit form, we can see that 4 copies of 1/10 is 4/10 or 0.4. Now let's use what we know about multiplying decimals using standard algorithm. So we have 0.1 times 4. Are we ready to multiply?
No.
Why not? How come we're not ready to multiply yet? Geffen?
Because the 4 and the 1 is not in the same
Geffen says we're not ready to multiply because the 1 is in the tenths and the 4 is in the ones. Do we need to multiply? Do we need to line up place value units like this when we are multiplying?
No.
No, we do not. Okay, but we are still not ready to multiply. Why not? Lydia?
Because you have to change the...
That's right. We have a decimal here. We don't know, when we multiply using the standard algorithm, we don't want to have decimals. We want to change the problem. How can I change this part so that there's no more decimals? Shivani? Good, so let's write change times 10. If I do that, the digits will all shift to the left, and the decimal point will be there. So I have 1 times 4. What's 1 times 4? 4. Is my final answer 4? No, because I changed the problem. I had to change, so I have to undo. If my change was multiplied by 10, what should my undo be? Divided by 10, which would shift all the digits to the left. So then my answer is 0.4. So we can see we get the same answer if we use unit form or we use the standard algorithm. Let's go back and talk about what Geffen was talking about. She said I need to line up my place value units. Sometimes I do. What operation requires me to line up all my place values? Geffen? I don't need to do it when I multiply, but I need to make sure I line up my ones with my ones, my tenths with my tenths, my hundreds with my hundreds when I add. Very good. There you go. Okay, now let's use this in fraction form. How do I write 0.1? How do I say that in words again? 1/10. So that's the same as 1/10, isn't it? Times 4. What's 1/10 times 4? Well, it's 1 times 4 all over 10, which is 4 over 10. How do I say 4 over 10 using words? 4/10. Is that the same as 4/10? Yes. So we can once again see that the fractions and the decimals are related. In this case, we do not need to simplify the fraction because I want you to show how 4/10 as a fraction is the same as 4/10 as a decimal. I have 0.1 times 0.1. How do I say 0.1 using unit form? 1. So this is 1/10 times 1/10. Okay. Now let's use standard form to multiply it. What's 1 times 1? 1. If I have a tenth and I multiply by a tenth, what do I get? 100th. Good. So the answer we think should be 100th in unit form. Now let's use the standard form to see how we can multiply this using decimals. I have 0.1 times 0.1. What do I have to do to 0.1 to make it into a whole number? My change has to be what? Times 10. What about this one? What do I have to do here too? Times 10. Now I have 1 times 1, which I know is 1. But in order to undo my changes, what do I have to do first? My first undo, to undo that, has to be divide by 10. If I do that, my decimal point moves here. How do I undo my second multiplying by 10? I have to divide by 10 again. So I have to move it one more time. So my answer becomes 0.01, which is the same thing as 100th right there. At your table groups, explain why I had to multiply by 10 2 times to change it and undo 2 times. How can I write this using fractions? How do I write 0.1 using a fraction? 1/10, and then the second one is also 1/10. Now we know, because we now know how numbers work, we can do 1 times 1 over 10 times 10, which is 1 over 100. But I want to show you how you can prove this works. Okay? Here I have a hundreds chart. There's 100 boxes there. It's 10 by 10, so that's 100 boxes. You don't need to draw one in your own notebook. You'll have a chance in your problem set to do this later. I don't want you to waste time drawing this. But let's go through it together and see. How would I show this 1/10? Well, I would have to shade in 1 out of 10 of the rows. Do you guys agree? Is that 1/10? What do I have to do? I have to label it. Okay, do I want all of that 1/10? No, I only want what of that 1/10? 1/10 of it. By the way, is that really this 1/10?
No.
It actually is the second one, isn't it? Because we always shade the second one first. Right?
Yes.
So now I've showed 1/10 on that chart, on that rectangular fraction model. Now, we don't want that whole tenth. We only want 1/10 of it. So luckily, it's already been split up into 10 going the other way. And here is 1/10 of it. Do you agree? So I'm going to label this as 1/10. How many units is my entire unit split into? 100, right? This entire thing has been split into 100 sections, yes? And how many of them are shaded in 2 times? So 1 out of 100. This relates what we had learned last week with the rectangular fraction model. And again, that's why this number works. Because to find out the denominators, we have 10 times 10. We find out how many units are in my whole entire rectangular fraction model. Do you see that? And then in order to find the numerator, we do 1, because there's 1 going this way and 1 going this way. So there's only 1 box that's shaded in double E. So again, did we get the same answer using fractions, unit form, and decimal multiplication? Yes, we did. We have to find, how do we write 6/10 times 2/10 using words? Well, we're trying to find 6/10 of 2/10. So when I model it, which fraction should I draw first? 2/10. Very good. So I know that there's 10 going across. So if I color in one row, what fraction is that? 1/10. Is that what I want?
No.
I want what? 2/10. So there we go. Now I have to color in 2 columns and label it as 2/10. Do I want that entire 2/10? No, I only want 6/10 of it. So I would have to cut it into how many sections going up and down? 10. 10 of them, right? But then how many of them should I color in?
6.
So here's 1, 2, 3, 4, 5, 6. And I should label this as 6/10. Now if I look at my rectangular fraction model, how many units has my whole unit been, has my whole entire box, this whole entire box, has been split up into how many units? 100. Very good. How many of them are doubly colored in? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So my answer is 12 hundredths, or 6/50ths, or 3 25ths. If you can simplify it, show all of them, okay? Very good. So now we've multiplied and we've modeled. Haven't we? We could also multiply a different way. We could also show that this is 6 times 2 over 10 times 10. Are there, and then which is 12 over 100, right? Of course, unless we simplify first, and eventually we'll get the same 3/25. Yes? Okay. Now, the second part of the question tells us to rewrite each expression as a multiplication sentence with using decimal factors. So how can I turn 6/10 into a decimal? That would be 0.6. Okay. What about 2/10? 0.2. And we know the answer should be 12 hundredths. So that means I write 12, and I need my rightmost unit to be in the hundredths, the 2 to be in the hundredths. So where does the decimal point need to go in order for the 2 to be in the hundredths? Tarun? Before the 1, and we'll put a 0. And I can show that, this whole thing is my multiplication sentence. 6/10 times 2/10 equals 12 hundredths. Looking at this problem, I see 1.9. That's the same thing as 19/10, isn't it? Which is the same thing as 19/10, isn't it? So if I wanted to rewrite this problem just using fractions, I could write this as 6/10 times, or of, right, 19/10. So if I wanted to multiply this and model it, if I want to model it, what do I have to do first? Which fraction should I draw first? 6/10 or 19/10? 19/10. So here's 1/10, 2/10, 3/10, 4/10, 5/10, 6/10, 7/10, 8/10, 9/10, 10/10. I've colored in my entire thing, haven't I? That's 10/10. How many tenths am I trying to color in? Okay, let's keep going. 11/10, 12/10, 13/10, 14/10, 15/10, 16/10, 17/10, 18/10, 19/10. So I'm going to label this entire thing all the way to over here as 19/10. We need two rectangular fraction models together to show this, because 19/10 is the same thing as 1 and 9/10. Here's 1, right? And here's 9/10. But I labeled them all together because we're looking for 19/10. Do I want all 19/10? No. I only want 6/10 of those 19/10. So here's 1/10. Do you see how 1/10 goes across both rectangular fraction models? Here's 2/10. Here's 3/10. Here's 4/10. 5/10. 6/10. And of course I need to label it. This is 6/10. So if you are asked to multiply and a number is greater than 1, you're going to need more than one rectangular fraction model. So here's how you would model 6/10 of 19/10. I don't want you to draw this in your notebook, but I want you to write yourself a step-by-step directions of how we were able to model 6/10 of 19/10. Go. One entire unit, which is this whole box right here, has been split up into how many sized units? 100. Okay, so we know that our denominator is still 100. How many of those are doubly shaded in, though? Well, on this box over here, we have 6 times 10, which would be how many? 60. And over here, do we also have 6 times 10? No. We have 6 times, 9. Which is? 54. So over here we have 60 of them. I'm going to write it in a different color, 60. And over here we have 54. So how many is that altogether? 114. So we have 114 over 100. Is that an improper fraction? Yes. How many hundredths does it take to make one whole? 1. So we have 1. And then how many would we have left? 14 over 100. Okay, go ahead and leave it like that today. 1 and 14 over 100. Whenever I'm asking you to show me how decimals and fractions are related, your denominator, you don't need to simplify your fraction if your denominator is a power of 10. 10, 100, 1,000, etc. Because that's how we show that fractions and decimals are related. If you leave it unsimplified and the denominator is 50 or 25, is that okay? No. No. Very good. Okay, now we're only halfway done. We also need to rewrite each expression as a multiplication sentence with decimal factors. So how do I rewrite 6 over 10 as a decimal? 0.6. Write it down. 0.6. And then we already have 1.9. Good. And what about the answer? 1 and 14 over 100. That's 1 and 14 hundredths. And that's how you would write down the multiplication sentence with decimal factors.